The next problem, in financing a new shopping center, the owner receives a loan of 20,000 pesos. At the beginning, at the beginning of each 6 months for 4 years. He agrees to pay all accumulated liability with the interest at the rate of 8% per annum semi-annual by a single payment at the end of 6 years. Find his payment. Find his payment. So, what's happening here? So he has a loan of 20,000 pesos per 6 months, which is for 4 years. 4 years. So 4 years, so 8 periods. 8 periods. But he will for this is for 4 years, no, 4 years. But he will pay one time, in other words, lump sum, no, single payment, but only at the end of year 6. Year 6. Okay. So he has a loan 20,000 per every 6 months. He will receive this for 4 years, but he's going to pay only at one time at the end of 6 years. So what do we do? First, we need to know how much how much is the value of the loan in total, right? And this is at the beginning. At the beginning, meaning annuity due, right? Annuity due. So we're going to use that formula A double dot or S double dot. Since this is a total payment, so we are going to solve for S double dot. So first, the given. So what are the given data? So 20 is R, right? Because he receives the loan. The loan is given every 6 months. It's not given as lump sum at the very beginning. So 20,000. R is 8% per annum compounded semi-annually. So I is 0.08 over 2 is 0.04. N is 4 years times 2. So 2 times 4 is 8 payment periods. And okay, so what else do we need? Okay, so we are to find single payment at year 6. At year 6. So as we mentioned earlier, to solve this, we need first to know a solution. We need first to know how much is the total liability, right? And to solve for the total liability, since this is an annuity due, then we will make use of S double dot, which is equal R times S of N plus 1 bar I minus R. Alright? So, substituting, our R is 20,000. Let's factor out R. S is, so S N I is equal to 1 plus I raised to n minus 1 all over I. But we don't have n, we have n minus 1. Our n is 8, so this is S 8 bar, 8 plus 1, 8 plus 1 bar, I, which is 0.04 minus 1. So we'll have 20,000 times 1 plus I raised to n plus 1, so raised to 9 minus 1. I is, what is I? 0.04 raised to 9 minus 1 all over, minus 1 minus 1 all over 0.04, another minus 1 for this. Alright? So, simplifying this, we'll have 20,000 times, let me check our calculator here. So, it's 10.582795 minus 1 equals 191,655.91. So this is his total liability. S double dot. But this is going to be paid after 6 years pa. So this is at the end of 4 years. Since he will pay it at the end of 6 years, it means we need to accumulate this for 2 more years. So 2 years is equivalent to 4 periods. 4 periods because this is semi-annual, so n equals 4. In other words, find the future value. So find future at n equals 4. So for the future value, P times 1 plus I to the n, so it will be 191.655.91 times 1 plus 0.04 raised to 4. This is equal to 224. So 224 210.30. So this is the what? The total liability, which he will pay after 6 years. So total liability to be paid in 6 years. So let's total liability at the end of 6 years. Okay? So for our last problem, in order to have 10,000 pesos in a fund at the end of 9 years, 2,000 pesos is deposited now, and equal payments will be added to the fund at the ends of 3, 4, 5, and 6 years. So find these annual payments if the fund accumulates at 4% 4%. Okay, 4% per annum. Understanding, no? So, how do we go about this problem? He wants the fund to reach 10,000 after 9 years. His initial deposit is 2,000. So this is at year 0. At year 3, year 4, year 5, and year 6, he will deposit a uniform amount. The goal is 10,000 in year 9. So if we are to draw our timeline, okay, so this is year 0. Maybe let's color the year. So year 0, year 1, year 2, year 3, year 4, year 5, year 6, year 7, year 8, year 9. So up to 9 years. So let's erase this part. Okay, so this is year 9. So at the end of year 9, this should be 10,000 pesos. But at year 0, he deposited 2,000. And then at the end of year 3, year 4, year 5, year 6, he will deposit a uniform amount. So this is annuity, right? So here, N is 4. N is 4. Okay. So, how are we going to solve for R? Let me see. At the end of year 6, how much is this money? How much is this money? This money now will be is just a compound interest, right? From F equals P times 1 plus I to the N. So F here is 2,000 times 1 plus what is R? 0.04 to the N. How many years is that? 6 years. What about 10,000? So 10,000 will be discounted, right? So this will be P. P equals F 1 plus I to the negative, how many years? 1, 2, 3 years. So negative 3, right? So P is equal to F, which is 10,000 times 1.04 to negative 3. So in other words, this is now the goal. It's the goal, it's S, right? So in other words, so first let's list down all the given. So given initial deposit 2,000. What about 10,000? 10,000 total money, which is S at the end of 9 years, right? So so S9. This is S9. Okay. So R is 0.04. So this is annual, so it's the same as I. What about N? N is 4. This is for the annuity. So N equals 4. N equals 4. So find Find R. How much is the annuity annually on year 3, 4, 5, and 6? So for our solution, your total money, so your goal is 10,000 times 1.0 plus 0.04 to the negative 3. That's the value, or that's the worth of 10,000 in year 6, should be equal to your 2,000 initial deposit plus the installment 1, 2, 3, 4. Right? In other words, that's 2,000 times 1 plus 0.04 raised to 6 plus S, annuity, right? With N4 I.04, isn't it? So we'll have what is S? That is actually, so we have S4 at 0.04. Oh no, SR. Ay nako, this is S4, which is equal to R S N, which is 4, I, which is 0.04, equals, what's 10,000? 10,000 times blah blah blah. Let's use our calculator. It's what? 8, so it's 8, 8, 8, 9.96 minus this thing here, which is equal to, how much is it? 2530.63. Okay, so we have R times, what is S? 1 plus 0.04 to the N minus 1 over 0.04 equals, how much is this? 8 minus, so it's 6,359.33. So therefore, R is equal to 6,359.33 divided by, how much is this? 1.04 raised to 4 minus 1 divide 0.04 is 4.246464 daw, which is equal to, divide 1,497.56. So this is how much he will pay every year, to be paid every year. So this is to be paid every year on year 3, 4, 5, and 6. Okay? So this is now our last problem. The topics will end here. So we will have our last quiz on Tuesday. The coverage would be the lectures of today. Okay? So I will upload this and maybe I'll just consolidate with the first video.